Okay, so what I want to do here is I want to show you a sort of maybe a little bit of a naive solution to the linked list. I like to use JSPin. I like to use it because I could set up some scripts pretty easily. You could do ES6 stuff if you want to on JSPin. When you're sort of trying to get a proof of concept of something, it can work out pretty well. Very often if someone ends up coming to me and saying, you know, they'll give me a big file of code and I can't figure out what's going on, my first thing is, hey, look, can you simplify it and put it up on JSPin, sort of break it down into what the sort of critical parts are. So what I'm getting at here is, just to see that this is working, I'm going to say console.log hello, and there's other sites that you could do this sort of thing with as well, but if I go to run this, this will say hello. If I go to run it again, notice that shows up twice, because one thing that JSPin does is it'll keep the console logs here. So I always do this, usually too, just so I'm working fresh, and you'll sort of get used to seeing me do this. Now, what am I sort of looking at here? I'm even going to name this very concisely. I'm going to create this LL, which is my linked list, right? I'll call it LL. And we're going to be very, very simplistic with this, because if you can end up adding to the head and traversing a linked list, then you could do the same exact thing with the tail as well. So just sort of looking at a couple of different things here. What I want to do here is I want to create a linked list, which is going to be a new LL. And I want to do something like LL add to head foo. And I want to maybe do something like add to head bar. Again, if you could add to head, you could also have a tail and add to tail. There's nothing that says that a linked list has to go in both directions. The bottom line with the linked list is that you have a starting point and you could end up traversing through the linked list. So I would then go over here and do a prototype. Again, we could use ES6 if we wanted to here, even in JSPin. And I could say add to head, and what are we going to be doing? We're going to be passing in a value. So just sort of looking at how this could end up working, we know that when we end up creating a brand new linked list, again, we're just going to go in one direction, and we'll end up setting the head to null. Okay? And just let's think about a very, very basic case. When we go to add to the head, let's just specify that we'll say, hey, look, if we don't have a head here, let's go over here and we'll say this dot head equals, and we're going to have a new node with our value. Because what a linked list does is it's going to give you the ability to sort of traverse through the linked list. You're going to start at a node, you're going to be able to move to the next node in the linked list. Now again, if we just want to keep this fairly simplistic here, one of the things we could do here is let's just pretend doesn't exist yet. This shouldn't end up throwing any errors here. Add to head, prototype. I don't have. No node. Okay. Okay, good. So let's go over here. Let's create this node. And let's keep this actually even, very, very simple. Let's just go in one direction. Again, we can go in one direction. We could go forwards and backwards. When we go in here with a value, okay, we'll go in here and we'll specify that this dot value equals the value that we're passing, and this is totally legitimate. And we'll say this dot next is equal to null. Okay, we'll end up setting this eventually. So if we end up going in here, let's just make sure that this runs without an error, which it does. So let's imagine that we're adding to the head. So what we're sort of looking to get at this point is that if we added to the head a foo, and then we add to the head on top of it, we're going to have this linked list, and we're going to have, if we traverse from the head, right, we have values of bar and foo, if this was working properly, right? It's not, but let's actually decide what we might end up doing with the linked list. Let's just suppose, for the sake of argument, that we have some method in our linked list that we could traverse through the linked list. And we could pass in a function. And this function will, again, we don't know, if you're using this linked list, you don't know exactly how this is working underneath the covers, but I'll tell you that underneath the covers, we're just going to basically traverse through the linked list. For every node that we have in the linked list, we'll call this function, and we'll go over here and we'll say console.log value. Okay? Now again, this doesn't exist. If we went to run this, we'd end up getting an error. But calling a traverse on this simply is going to get past a function. And what we're hoping is that internally this linked list knows how to traverse its own structure. And for every node that it encounters, it will call this function. Because if you could do this, you could search on a linked list to see if a linked list has a value. Okay? Again, we're only going in one direction here. And our idea is, hey, look, we're going to have this sort of non-contiguous collection of items. And they're going to be connected by basically specifying, hey, look, we're starting at the head, and we're going to keep on moving to the next until we don't have any next to go to. So what would traverse look like? Well, one thing we need to do is that if we don't have a head, just return, because we got nothing, right? If we don't have a head here, there's no way that we could end up traversing. If we do have a head, what we could do, we could set up a variable and say current equals this dot head. And we could do a while current. And we could traverse. Make sure if you do this that you end up setting the current's next value, or else you're going to be in trouble. And we'll say current equals current.next. Again, we're only moving in one direction. We're not moving backwards. And here we could specify that every time we end up going in here, we're going to end up calling this function with current's value. Okay? So let's just see what we have so far. Okay? Not all that helpful. This is not surprising. You can see that when we end up adding to head, we're only adding if we don't have a head. Right? But now let's take this scenario. And again, it's not like you're working with a ton of different code here. All you're seeing is that you have this structure where you're dealing with references. So we could put an else here, and let's just think about this. All right? This is sort of what I put on the board the other day, but it's actually a little bit easier. We know that if we're going to now add to head, one thing we need to do is do what? Create a node. Right? We know we're going to have a node. So right off the bat, we're going to have a node, and we'll specify that this node that we have is going to be a new node, and we're going to have this value. Okay? We also know that since we're adding to the head over here, we know that the next value for this node is going to be whatever the current head is. Right? We're adding this to the front. Okay? So we know that this node that we add, and we also know that as we do this, we're not destroying any references. Okay? There's no references that we're destroying. We could say node.next equals this dot head. So whatever the head was before, we're now pointing to it. Okay? And now, in order to get this node in our system, the last thing we do is blow up the reference by saying this dot head equals node. Right? We're creating a new node. We're saying, hey, look, we know we have a head on there. Okay? And we're basically saying the next value is going to point to this node. And then we blow up the reference because now our new head is going to be this node. And when we do that, we get bar and foo, which is exactly what we want. And, you know, just to beat a dead horse a little bit, we could go over here, foo bar, baz. So what I'm getting at here really is quite simplistic. First of all, you can create a linked list with not a ton of code that's here. Frankly, we could probably even have dried this out a little bit in terms of creating the new node as well. Maybe gotten it even a little bit shaved off a couple of lines here. But you can see, if you sort of think about what the structure is, and you sort of whiteboard the structure, you draw a couple of diagrams like we did last week, it's not that complicated. Again, we can make it more complicated if we have a method removed from head. Wouldn't be all that tough to do. We basically just find the value for the current head, see if there was a next value, and we would set the current head to whatever the head's next value was. If there was no current head, then basically we'd have an empty linked list at that point. Okay? We could do a search on the linked list because we have this traverse function. So we can do a search and traverse to see if we could find the value within the linked list. And all those other things of having the tail and adding to the tail and removing from the tail, this is basically just French pastry on this concept. The concept is really what here? Linking objects. That's all. One object has a reference to the next object. And if you think about it, right, the whole idea with the linked list is that you can keep on adding to it. You can find out what's in it. Okay? These things could be stored in different places of memory because you just have references to objects. But the real meat and potatoes of this thing are these 3 lines of code here, right? This is really the logic that you'd end up drawing out, right? Create the new node, make sure the node that you're adding, its next value is pointing to the current head, and then end up blowing out the reference. So 2 things to sort of take away here, I think, is passing a function to another function that's going to be able to do some iteration. And this was actually not even part of the workshop, but we're going to end up doing, when we end up looking at working with the DOM, we're going to traverse the DOM, and we're going to do something very similar. We do game of life, we're going to do the same thing. And what we're doing is we're saying, hey, look, give us a method to loop over this structure, okay? And let us do it so that we have no idea what the internal structure is. We don't care how these things are connected, okay? In fact, if we're using this linked list, do we even know what the hell a node is? Node is totally internal to this structure. We're never getting back a node, okay? We're always dealing with basically being able to connect values together, which is what a linked list is. So again, it's not that, if you're sitting around and saying, boy, I really need to go back to the workshop and redo the workshop, do this. Write it, see that you could create a linked list, okay? Again, this is the sort of second part of the workshop. Redo yours so that you have a tail, and you could end up adding to the tail. And it just is going to be a flip of this, and then end up combining these things together. Okay? So again, if you sort of understand what these concepts are, I think that this is more critical, and I think maybe you get a lot more out of this because it's a lot less frustrating than going in and having specs that are testing for all these different pieces. Again, if you wanted to find out how many elements were on the linked list, you could write a traverse method that traversed through the linked list and did a counter, and then you'd have the size of the linked list as well. Let me ask this. I always like to ask this question. Is there any line of code here that you don't understand? Are people happy with references and assigning references, right? I mean, here, when the thing to sort of look for is that when you have a reference and you assign something to it, you're blowing out the reference from before. But we're not doing that. We're getting the reference to this object, whatever the head was. That's the real, I think, critical part of this. Again, 2 things. Critical things are passing functions in that do some iteration or do some work for you, okay, to make this a sort of useful structure, and dealing with references. I think those are the two key things. All right, let me save this.